In this optional video for this unit, we're going to talk about some networking concepts that are related to cloud and virtualization. So really, I just wanted to level set everyone on some of the terms and some of the vernacular that we use in networking and how that might affect um, virtualization and cloud computing. So, and of course, to understand security, it's good to understand these concepts as well. Um, Networking, as you probably know, is a topic unto itself. So for many of you, this video is just a review of a lot of the things you've probably learned in other courses, and is really just a prerequisite for some of the specific things that we have to concern ourselves with in cloud and virtualization. So I don't want you to think that this video is going to tell you everything you need to know about networking for cloud and virtualization. It's just a kind of a list of topics that would be good to review if you're not familiar with some of these topics. So or if if you need a refresher on any of these topics, I would recommend taking a look at some of these topics in more detail. So the first one is network address translation. Um, as you know, there's only a finite number of IP addresses on the internet. So one of the things that we do is we assign private IP addresses on our internal networks. What network address translation does is it maps a public IP address to an internal private IP address, so that you can assign a public IP address to a system that's inside your internal network. One of the things I should point out here is that network address translation typically is a one-to-one of public IP address to private IP address. A lot of people, when they think of network address translation and how it works in reality, many times they're talking about port address translation, or PAT. This is where you can have many private IP addresses on your internal network, but they can all go to the internet. They can all access the internet using one public IP address. So I could have 10,000 computers in my network, but they could all appear to come from a single public IP address when that traffic is initiated from within my network. So that is port address translation, or PAT. There are some other names for these as well, but for the purposes of this course, just make sure you're familiar with the concept of natting and padding. And then there's subnetting and supernetting. And of course, subnetting, I think, I'm sure all of you have taken courses where you learn about subnetting and you learn how to do subnet masks. Everybody cringes when I am in a class and talk about subnetting because, oh, we have to do subnet masks. Um, they're not complicated, but and I'm not going to ask you to do subnet masking in a course like this, but of course you really need to understand what subnets are and really what networks are in general, kind of how that routing works and what the different parts of the address mean. So just make sure you're familiar with that. And likewise, we have VLANs. It's good to be familiar with what VLANs are. VLANs are actually kind of important for clouds and virtualization because we rely very heavily on this layer 2 routing that happens, or layer 2 switching, I should say, that happens with VLANs and with network segmentation. Sometimes we do this network segmentation in cloud environments virtually. Sometimes there's a need to do this also physically, but it's one of the tools that we have in IT security, and especially so with cloud and virtualization. A lot of times we need to take advantage of VLANs and some of the protocols that support VLANs. Basically, VLANs work by using some of the header and metadata that comes in the not the segment, or the frame. I had to remember which header it is in the frame header. So just make sure you're familiar with the concept of VLANs and how that might be used. And then we have oops, let me skip that slide. So we have network optimization. So there's various ways to do network optimization, but just be aware that there are tools out there that can monitor the network. They can monitor for things in real time that may require attention from a system administrator, or they can automate the optimization of the network by ensuring that caches are not filling up, that CPUs are not overloaded. They can reset devices and things like that. There's also optimization protocols that can do various levels of compression on the payload and packets and things like that, and in segments. So lots of different things that can happen with optimization, but I guess for this class you just want to be aware that we have these different optimization techniques. There's WAN optimization, there's monitoring and things like that, and management of network infrastructure that can help us optimize our networks. And of course there are tools that help us do that. I'm sure all of you are familiar with this term, WAN, or wide area network. So whenever we're talking about the WAN, we're talking about basically the internet, right? So the WAN is the internet. Here on this slide it says nationwide carrier network, but really the WAN, for the purposes of the when we talk about networking today, the WAN is typically the entire internet. So anything that's accessible through the public switched internet. A local area network, on the other hand, is the internet that's available within our own domain, within our own infrastructure. So typically, your LAN is your network that's internal. That could be multiple locations that are connected via VPNs, which it gets a little complicated because now we're talking about the WAN as sort of a transport mechanism between our different LANs, but that's perfectly acceptable. But just make sure you're familiar with the relationship between a local area network and a wide area network. And there's even other types of networks like a metropolitan area network, which could be, for example, a city or a campus or an office park that has many buildings all interconnected. So those would be examples of metropolitan area networks. Quality of service is important to understand for cloud computing because quality of service is basically it's how we define what traffic to prioritize on our networks. There's been a lot of talk lately about net neutrality. I'm sure a lot of you are familiar with net neutrality. I think there's a lot of misinformation about net neutrality as well. There's kind of, I think there's a lot of fear about net neutrality, about not having net neutrality, in the sense that ISPs could define certain websites and things like that they could prioritize. But really, what quality of service is about is making sure that services that need to be prioritized because of because it's inherent in that service or in that protocol that it needs low latency, should take precedence over protocols that can suffer through that latency. A good example is real-time chat, maybe video conferencing. So if you're doing video conferencing, the traffic on those ports, we should probably try to prioritize because it's going to be much more noticeable to users than, say, doing file sharing or something like that. So, I think, in my opinion, I think net neutrality is a lot more complicated than people lead us to believe. I think some people kind of simplify it that, hey, if we don't have net neutrality, the internet's going to break because ISPs are going to charge us to get to Netflix. And there's kind of a happy medium there where maybe we shouldn't have ISPs that can control that traffic going to Netflix, but we should give our ISPs at least the ability to control at the protocol level to make sure that they can prioritize traffic for these different services. So I think there does need to be some QoS. And of course, we're concerned about QoS on the cloud, obviously, because we're using the WAN extensively, right? We have to use the WAN because we're connecting to everything over the cloud, over the WAN. So that'll come up again. We'll talk about that in more detail later on. And of course, the bandwidth is basically how much bandwidth you have or how fast your connection is. I have some other videos as well that talk a little bit about how bandwidth works in some of the different technologies that support high bandwidth or broadband and narrowband and so forth. But certainly a concept that you should be familiar with to understand the impact of bandwidth on your network's performance. Latency is a way of determining the delay or the time it takes for data to traverse the network. So here we're talking about delays, and this relates back to QoS, or quality of service. Data compression allows us to send more data with less bandwidth. Sometimes data compression is a tool that we have to increase the effective bandwidth on any given link. So sometimes we can use so sometimes that optimization I talked about earlier uses data compression to achieve the optimization that we're looking for on those slower connections. Almost every networking device has to cache something. Typically, networking devices, they have to cache for the purposes of logging where traffic is going and where it's coming from. A good example of that at a very basic level is state versus stateful devices. So, for example, a router that's stateful has to keep some kind of record of the acknowledgement and the sequence numbers in the segment headers in order to return traffic from whence it came and to understand that there's an established connection between two nodes. And all of that has to happen with caching. And if you have a device at home that's a router, you may have noticed that periodically you have to restart that device. The lower end devices, typically you have to restart them, or else they, because sometimes the cache is, that's one of the reasons they have to be restarted. The cache is full, it locks up, there's too much memory if you're doing too much stuff with that device. So we don't want that, of course, in our enterprise network, so it's important to understand how caching works, so you know how to avoid those problems. Load balancing is basically when we can take traffic that's coming from one set of nodes and basically send it to multiple nodes that act as a cluster. When I talk about load balancing, it's kind of like a 747, right? So a 747 has multiple engines. The idea is that any engine can fail and the other engines can take over. And a load balancer is what decides which traffic goes to which engine. So load balancers are important in redundant networks and high availability networks. So typically you'll find a load balancer in many cloud environments, for example. It helps us determine where that, not only where traffic is going to go based on the set of devices that we have in a cluster, but also is aware that when clusters go down, it can redirect or shunt the traffic to other nodes. So as far as troubleshooting network connectivity, there are lots of tools in our toolbox that we can use to do that. And this slide shows you some of them. I'll talk about them though. So ping is a tool, obviously, that we can use. I think most of you are familiar with ping, but I'll talk about it just in case. It's a tool you can use to check to see if you can connect to another computer on a network. So you use the ping command, you put in the IP address you're trying to reach, and it tells you whether the destination is reachable or not. A trace route, or trace RT in some platforms, takes ping a step further. It does the ping and it tries to determine all of the IP addresses that you have to connect to in order to get to the final destination. So a trace route gives you more information, and it can reveal the latency or any connection issues between you and your destination. So that's the trace route command. There's also one called path ping along with trace route. I don't think I have it in this presentation, but path ping is another command that can do that. That gives you a little bit better statistical analysis of those links. So Telnet is another tool. A lot of people say, well, we can't use Telnet anymore, it's not encrypted. But the thing about Telnet is it's a great tool for checking to see if you can reach a specific port number. So ping and path ping and trace route, they can't tell you if you can access a port number. They just tell you whether or not the machine is listening on an IP address, or whether it can tell that a machine is reachable on an IP address. Telnet, on the other hand, you can open a Telnet console, connect to a specific port number, and then you could tell whether it's listening on port 80 if it's a web server, for example. The thing about Telnet is sometimes you do a ping and the ping says the destination is not reachable because ping is, or the underlying protocol that ping uses is blocked by routers and switches and firewalls and things like that for security reasons. So you're going to assume that you can't get to it. But then if you open Telnet and try to connect to a specific port, that might work because you're not using the protocol that path ping or traceroute uses. So Telnet is also a good tool in our toolbox for network troubleshooting. Netstat will tell you all of the network connections that you have on a given machine, or really any device like a router. Most routers and firewalls also use the netstat command. It's in Windows, it's in Linux, and ergo it's also in Mac, and of course every device is under the hood really probably some derivative of Unix or Linux or BSD or something like that. So the netstat command will just show you all of the active connections. You can see what port numbers it's listening on. You can see what port numbers you're connecting from, and you can get a sense of any active connections on your system. The NSLOOKUP command, basically NSLOOKUP is for looking up IP address to domain name mappings. So you can use that to see what a system's IP address is from its DNS name, or look up a DNS name from an IP address. The ipconfig or ifconfig command, if you're in Linux or BSD or Unix, basically is to show you what the IP addresses are that are configured for various interfaces on a device. And of course, you can try that on your virtual machines that you installed before, but I'm sure most of you are probably familiar with ipconfig and ifconfig. The route command is how you determine, is the command that you use to tell the computer how to determine which interface it uses to connect to which networks. So if you have more than one network interface on a device, you have to tell it which networks are reachable through which interface. So if you, it's sort of like having two mailboxes. If you want to send a letter, you have to know which mailbox to put your letter in. So something has to tell you which mailbox to use. That's kind of how the route command works. ARP is the command that gives you information about MAC address to IP address mappings. So it'll tell you which IP addresses are mapped to which MAC addresses. Sometimes you have to clear that table, the ARP table. We'll talk more about ARP and how that affects network security and cloud security later on. So we'll talk about that again. A lot of these we'll revisit again as we go through some of the security concerns. All right, so it's important to review documentation and device configuration settings. Sometimes we can use audits to do that. It's important to have that documentation. I think a lot of people forget to even have the documentation for these devices. So it's important to make sure that you have the documentation and that you can apply that documentation to networking devices throughout your infrastructure. Periodically, you have to review system logs. This is an important step in doing not only auditing, but also verifying configurations, and also intrusion detection and prevention systems use system logs in order to detect any suspicious activity. And again, we'll talk about IDS later on with cloud security. All right, so some common network protocols, ports, and topologies. So trunk ports are used on networking devices to interconnect more than one network on a port. And I'm sure you can guess that trunking is pretty important for cloud and virtualization, because we have one network port through which many different networks have to interoperate. So, because virtualization allows us to have so many computers on a single machine through a single set of interfaces. So trunking does become kind of important. We'll talk about that later on as it specifically applies to cloud and virtualization. Port binding is basically when you have some service that binds to a port or listens on a port. And again, we'll talk about that later on. So some common TCP/IP ports. Let's just go through a few of these. I'm sure most of you are familiar with many of these ports, but port 80 is typically used for the World Wide Web or HTTP protocol. Port 21 is for FTP. Also, port 22 is used for SFTP and SSH or SCP. So if you want to securely connect to a server to copy files or to log into the console to run commands, you would use port 22 for that, for things like SSH. Port 25 is SMTP, though it's not commonly used anymore. Most people use the encrypted variations of SMTP, but just to be aware of what that is. Port 53 is typically used for DNS. It can be TCP or UDP, but typically it is UDP for port 53. Port 443 is HTTPS, so it's a secure version of HTTP. Port 68. So port 68 is not as common, but it's excuse me. Sorry. So port 68 is basically a protocol. Well, there are various protocols, but they universally use port 68 for automatic configuration. So I talked earlier about thin clients. So thin clients, some of the protocols they use to download their configurations and connect to a server to bring up its virtual desktop from a virtual desktop server, a lot of those rely on your use port 68 for those protocols. All right, so continuing, so some common protocols. We talked about ports. Some common protocols are HTTP, which is web, FTP, which is file transfer, HTTPS, which is the secure version of web, FTPS, which is not the same as SFTP, which is a secure variation of FTP, though I don't think it's as widely used as SFTP on port 22, which we talked about before. So SFTP is the other one, which is also used by SSH, which I talked about before. So SSH is basically how you get a shell on a remote computer. You can use that to basically run commands on a remote system. It's very similar to Telnet, but it's much more secure because it's encrypted. DNS, again, I'm sure most of you are familiar with DNS, but it's how it's sort of like the phone book of the internet. It's how you can look up an IP address if you know a system's domain name. So, for example, you can look up the IP address for google.com using DNS. In fact, your browser does that automatically when you type in google.com. DHCP is how computers get an IP address on a network. And again, port 68, right? So that's one of the ways that you can or DHCP listens on port 68, which we talked about before. So that's how your computer gets an IP address automatically, among other settings. It also gets the default gateway, your DNS addresses, uh, any other network protocol configurations that can be done through DHCP, uh, like NetBIOS and so forth. SMTP is the Simple Mail Transfer Protocol, which we talked a little bit about before, but basically it's how you can send email on the internet. So some types of networks, obviously, we know what the internet is, but an intranet is basically our internal network, right? So our interconnected internal networks we usually call an intranet. An extranet is the portions of our internal network that are accessible to business partners. So it's not a publicly accessible thing. It's typically things that we expose to partner companies or to companies or organizations through which we're somehow coupled that need access to information within our network. And then finally, we have the internet, which I think everyone knows what the internet is, but that's our global public network through which we can all exchange information. So that's some of the terms for networking that you should be familiar with. I didn't want to spend a lot of time on each one of these topics. Again, you could take a whole course on all these things that I talked about in this presentation, but hopefully it's a nice little refresher for you on the different concepts that you should be familiar with as far as networking goes for cloud computing and virtualization.